Everyone, this is Raju Bhandari here. Once again, I welcome you all on my YouTube channel with the new assignment. In this assignment, we have to study how to draw the sine and cosine wave using assembly language programming. As we have to execute this assignment in Windows operating system, so here we have to study the different new system calls in Windows operating system. As we know, the Windows operating system mainly consists of two basic components. The first one is BIOS and another one is the DOS. The BIOS stands for basic input output system and DOS stands for disk operating system. So basic input output system mainly deals with all input output devices related to the system, and DOS mainly deals with all operating system functionality. So in this assignment we have to draw the sine and cosine wave. For that we need to set the video mode, and in BIOS already for setting the video mode some interrupt and function is already defined that we have to use for setting the video mode. In this case the function value, function value is goes into AH, and that value is nothing but 00 along with AL value is equal to 6 and INT 10H. So this particular system call is there for setting the video mode. For setting the video mode along with AL value is equal to 6, this indicates that our screen is having the resolution of 640 by 200 with two colors, that is nothing but white and black, with adapter CGA or EGA. CGA stand for color graphics adapter and EGA stand for enhanced graphics adapter, along with the video RAM address. This address is also fixed that we need to call for setting the video mode, and address is B800. So with this system call the video mode is set in the system. So whenever we set this particular video, then we are able to draw, visualize, write or read the pixels. And for the second functions that we need to study for this assignment is writing the graphics pixel on the screen. And for writing the graphics pixel on the screen, the function is given, that is 0ch, that we need to move into AH. The second value that we have to move into AL, that is 01. The 01 represent the color number. Color number may range from 0 to 15 in hexadecimal. The page is already mentioned here. The page value we need to mention in BH. The x1 represent the x coordinate value, and y and SI is nothing but the y value. That value goes into the dx along with the int 10h. So when we are executing this function in a program, then one pixel is right on the screen. So this is all about the BIOS interrupt that we need to study. If you want more information about BIOS interrupt, then just click on the link. You will get the detailed information about BIOS interrupt. If you observed here, the different BIOS system calls are given, and these system calls are executed with int 10h, interrupt 10h function. So see here, for setting video mode we need to put 00 into AH, that we have already studied. Then different functions as well as working along with the int 10h is mentioned here. Setting the cursor position, getting the cursor position, then active display page and all. And we have already studied this one also, that we need to execute in our program, that is the right graphics pixel, that is AH is equal to 0 CH, then AL is nothing but color. If you want to see the different colors which are available with your system, so just click on this link. When you click on this link, you will get the different colors which are available along with the BIOS. See here the BIOS color attributes and the value which we have set in our program. I think so the value we set in our program is 1. So if you observe the color attribute 1, the 1 represent blue color. That means whatever pixel we are drawing on the screen, that is nothing but the color, that is nothing in blue color. Okay, but as we are running our program in grayscale, the color combination is only black and white. So you can put 00 also there, that is not an issue. Then proceed next. So this is all about BIOS interrupt. Then some DOS interrupts are also mentioned, as we already studied different interrupts in NASM, that is net wide assembler. Similarly we have to study the different interrupts related to MASM as well as TASM in Windows operating system. NASM is in open source operating system, and MASM and TASM is in Windows operating system. The first system call is display. We already know the display call in NASM, that we have already studied in many more assignment. Here we need to study how to display the message on screen or console. Here the message value is loaded, that we can say the effective address. So the effective address of message is loaded into DX along with the function 09 into AH and INT21H. So we can say the DOS call is executed with the help of INT21 interrupt 21H. Then for exit, again one system call is mentioned here, that is move AH, 4CH along with INT21H. Then in this assignment, as we need to plot the multiple pixels on the console or on the screen, so we need to convert the degree value into radians, because we have to deal with some trigonometric function. As such, there is no difference between degree and radian, because no one is inferior, no one is superior. Just for performing some trigonometric function, we need to convert the degree values into radian. And as we have to plot the sine as well as cos wave, so the values related to sine and cos are mentioned here, ranging from 0 to 2 pi in radian, and ranging from 0 degree to 360 degree in degrees, that means angle values. But we need to consider the radian values as per as our assembly language program is concerned. Then here we have already studied the structure of assembly program in NASM. The structure is nothing but section.data, section.bss, section.code. Similarly, the structure is somewhat similar, but with minor changes. The changes that we need to see here. The first change is we need to mention the model first. So dot model small. The reason behind writing dot model small is nothing but your program is having only one data segment and one code segment having size of 64 kilobytes. We can change this small by large and huge. In that case, the segment sizes may vary. That means more than 64 kilobytes of data segment and code segments are also possible. But in our program, we are going to consider only the program having size of 64 kilobytes or less than 64 kilobytes. If we need to use the stack in our program, then stack is also mentioned here, and we have to declare the stack dot stack 100. The size of stack is 100 here. In similar to section dot data, we have to declare the data segment here, and data segment is declared with dot data. Then similar to section dot text, one segment we have to declare the code segment here, and code segment is declared with dot code. As we are doing this program in 80386, that's why dot 386 is written here. And main is indicating us the start of program, and end main is indicating the end of program. We will continue with the practical session. I think so the theory part is clear to everyone. The interrupt, BIOS interrupt, DOS interrupt, then why to convert degree to radian, and what exactly the structure of program is clear. We will begin with the actual code. Here we have already studied why model small is taken, because our program is having code segment and data segment having size of 64 kilobytes or less than 64 kilobytes. As we need to perform some push and pop operation, that's why the stack is defined here, and the stack is having size of 100. Then dot data, here the data segment is initialized, and the messages, variables, constant, everything is declared here in data segment only. So data segment is declared with dot data. Then as this program is having or is dealing with the sine wave, that's why we have written sine here. If there is only one single change is there in cosine wave, that we will see later on. But if you want to make changes in this assignment, you just write down, instead of sine, you can write down cosine here. So it will show the wave of cosine or cos. But as this program is having the logic of sine, that's why I will write down the sine again here. Then we have taken the value of x at 0 initially. Why the 0 is taken, that I will tell you later on. Then x AD value is declared here, that is defined double with the 3 value. This 3 will decide the height of the wave. That's why 3 is taken. If we will increase, if you want more height, then just change this 3 value by 4, or 4 or 4 value by 5. But here we have taken the value of of any wave, sine or cos. The height will be 3. Then we have taken one variable, that is 180, and the value which is stored in 180 variable is 180.0, that is 180. Then 60 and 100, both these variables are taken because we have to draw the full wave. As we have written 60 here and 100 here, but the values we have taken is 30 and 50, half of. The reason behind that is because half of the wave go in positive portion and half of the wave go in negative portion. That's why the variable names are 60 and 100, but the values are 30 and 50. Then we have initialized the value of row as 0 and column as 0. That means x and y coordinate will begin from 0 value, their initial position. You can make this position as a 50 also, as 20 also, or you can change the row and column, both the positions, by any other values also. Now the value of x cursor is 0 0, value of y cursor is 0 0 again. Again we can change this cursor values by any other values because our resolution is 600 by 200. Then we have taken the value of count as 360 because the whole wave running from 0 to 360 degree, or if we consider it in radian, then it moves from 0 to 2 pi. So that's why the count value is taken as a 360. Then the value of x1 is taken here as a 0, that we will see later on. So this is all about the initialization of values or variables in data segment, and that is represented with the dot data here. Then move towards next part. The code segment is initialized here. That's why we have written dot code, then dot 386. As this program belongs to 80386, that's why dot 386 is written. We can make it 486 also, we can make it 286 also, depending on the program that we are doing. Here we are initializing the data segment here in the main. The reason behind declaring or initializing the data segment here in the main is we have to use all these variables as well as messages in the code segment, and we need to fetch all these values into all the values of data segment into code segment. That's why we have written here the value move ax comma at the rate data, and then move ds comma x. Whatever values come from data segment goes into ax, and then ax is moving the values into data segment. Because we cannot directly initialize, or we cannot directly write move ds comma at the rate data. That's why the value first move into ax, and then x value moves into data segment. Now as we have studied earlier in this video, we need to set the video mode. So with the help of this BIOS interrupt and function code 00, we are setting the video mode here. Video mode is nothing but the grayscale mode along with the resolution 600 by 200. Then as we need to perform some complex operations, some divisions, some multiplication operations we need to perform, so we are initializing the coprocessor here because coprocessor is performing the complex operations very well. Then we are loading the value of pi. For loading, as this is one of the constant value that we have already studied in the coprocessor unit, so FLDPI will load the value of pi into top of the stack. Then that particular value is divided by 180 because we need to convert the degree into radian, and the formula for converting degree into radian is pi divided by 180. Then we are multiplying that particular value by x. X is nothing but the 0 here. Initially the value of x is 0. Here if we consider here, then the formula for that is, the formula for calculating the sine wave is a sine pi divided by 180 into x. So out of this particular pi divided by 180 into x value is already find with the help of this instruction FLD pi FDIV 180 Fmal. Then sine function is working in conjunction with these three instructions. So whenever we are loading the value of pi, then we are dividing it, when then we are multiplying with x, then sine function is also executing along with that. This particular part I think so clear to everyone. Then in next part we are multiplying the top of the stack value, that means this total value by 60. The value of 60, or the 60 variable value is nothing but 30 here. So till this instruction fmul 60, we got this particular result, 30 sine of pi divided by 180 into x. Then we are loading the value of fld, then we are loading the value of 100 into top of the stack, and that value is nothing but 50, because we have to perform this subtraction in the next step. That's why we have loaded the value of 100 here. Then we are subtracting that particular value from the result that we have already calculated. That means top of the stack is subtracted from st of 1, and the total value is nothing but 50 minus 30 sine of pi divided by 180 into x. So this particular logic gives us the value, or gives us the actual value of first pixel that we need to plot. Then as we know the value of y cursor, and this instruction we have already studied earlier also, FBSTP, this particular instruction will convert the extended long real format into 80-bit BCD format. Then we have uh, store this particular value, or we have converted this particular value. Then we are loading this particular value into ESI. Then for plotting the pixel, the value of pixel we already got from this particular logic, that value we need to draw. Then for plotting the pixel, the BIOS system call is already studied, and with the help of this system call we can easily plot the pixel. The value of x1 is nothing but the value which is already mentioned here, that is 0, and the value of y is also mentioned. The value of y is nothing but the value of y cursor, means y cursor value will stored into SI. That's why SI value we are moving into TX. So for plotting the first pixel, we are having the value of x also, as well as we are having the value of y also. And along with, and by executing the int10h function, the first pixel is plot. Then we need to plot the next pixels also. For that we are incrementing the value of x1. Now the value of x1 will become, the initial value is 0, but now the value of x1 will become 1. Then we are loading the value of x, as we have already calculated the value of x from this. Then we are loading that particular value, and then we are decrementing the value of count. The count is initially 360, but now the count is 359. Then again we are jumping back to up 1, and this routine is executed till the value of count will reach to 0. That means this particular loop will execute from 0 to 360. That means total wave in positive direction as well as negative direction is completed here. Once the value of count will reach to 0, then once the loop is executed, then we come out of the loop, and we need to display the message. And for displaying message, this particular DOS interrupt and function we already studied. So for displaying message, we need to load the effective address of message into DX. The value of 9 we are moving into AH, and along with the function int21h. And then once the program is executed very well, then we need to take exit. And for taking exit, function number 4ch along with 21 is given. In this fashion the program is ended. Now we need to run this assignment in DOSBox, because we need to plot the pixels. So DOSBox you need to install in your system, and once the DOSBox is installed in your system, then you need to execute, or you need to follow these steps that we will see right now. So for running, here we have to write TASM is already installed when you are installing DOSBox. In this way, drive C is mounted, because TASM is there in C drive. Then we can jump to C drive. Once you are on C drive, then check it out the program. I have copied the program in TASM folder. Is it available? Yes, the program is available here, that is wave.asm file. So we can run this assignment, and for running 3 steps we have to execute. TASM wave.asm. This is the first step. If there is no error, then it will show your file is assembled properly. Then the second step we have to execute, that is T-link. We have to link the program. T-link wave. And finally, once exe is created, then we need to run exe file. So wave. If you observe here, the sine wave is plotted in positive, half wave is in positive direction and half wave is in negative direction. Total 180 plus 180, that is 360, that is nothing but pi plus pi, that is 2 pi. So in this fashion the sine wave is plotted. If you want to plot the cos wave, you just need to make one change in your program, and that change is nothing but you need to write, instead of sine, you need to write f cos here. If you write f cos, then the program of cos wave is also executed. Only the change in sine and cos wave is, the sine wave will start from 0 from here only, and the cos wave will start from 1, because depending on these calculations. So whenever we will perform these calculations, initially we will get the value 0 in sine wave logic, and we are getting the value 1 in cos program, and then accordingly both the programs are executed. The difference that I already cleared with you, the sine wave start from 0, cos wave start from 90. Thank you so much for watching the video.